Hello, everybody. My name is Tyler, and my partner Isaac and I wanted to predict upsets in the March Madness basketball tournament using a sum of trees model called BART. The data set that we used was the last 10 years of the March Madness tournament, including each game's result as well as each team's season-long statistics. And what we wanted to do was figure out which statistics were the best predictors of an upset. Unlike similar tree models, the Bayesian additive regression tree incorporates multivariate components in its construction. And this allows for a lot of flexibility when you're dealing with different parameters or different sets of data. For example, we'll deal with different predictive statistics in our different models, and we will also deal with a certain number of games as our training data to train our models, and then a certain amount of test data to predict on. To implement our BART model, we used the BART machine package in R, and we actually created a cross-validation model with the BART machine CV function. And the key components of that function are a data frame of predictor variables, so that will be of our choice model by model, and then Y, our response variable, which in our case is categorical whether or not an upset occurred. The last component is the number of trees that you will construct in the model.
Next, we implemented our BART model in R. By way of the BART machine package, we fit models on training data using the hyperparameters recommended by Chipman and others. We then used a validation set to tune a prediction classification threshold, and then we tried each model on our test data set. Because of runtime and memory issues on Swarthmore's RStudio server, we could not try all predictors at once, so we split into 3 models described as follows. The first model just used the season-long statistics of each team in a given NCAA tournament game. The second model also included both teams' performance against power conference teams, i.e., how did they do against the big schools. The third model included both teams' performance over the past 5 games, i.e., did a team have momentum entering the tournament. We then, as reported by the BART machine package, took the most important predictors and built a fourth model using those. Our model's performance was limited, likely for 3 main reasons. First, because of memory and runtime issues, our MCMC sampling was restricted and likely did not achieve full convergence. Second, additional other predictors, such as a team's, say, age or experience, may have been more helpful in predicting. And third, March Madness is hard to predict because it is exactly that. It's madness. But nevertheless, this was a really good experience. A, learning a new package in R, and B, learning a new model and predictive algorithm.